Finally, let's compare linear and exponential functions. Recall that a linear function is a function in the form a times x plus b times y equals c. This is often called our standard form of a line, or y equals mx plus b, which is called our slope-intercept form, which you might be more familiar with. An important characteristic of linear functions is that we have a slope, or the rate of change of a function, and we have a y-intercept, or initial value. It turns out that the slope, or the rate of change m, describes how the function is changing over time, and it's something that is added to the function each time step. Exponentials also have a constant number that factors into the way it changes, but it does so in a different way than linear functions do. Specifically, with a linear function, we add the constant change, we add the slope, each time the input goes up by 1. On the other hand, for exponential functions, we multiply by the constant change each time the input goes up by 1. Let's take a look at what that looks like. Let's use this idea of change to identify whether these sequences are linear or exponential. We'll notice that for this first sequence here, to go from 2 to 3, we add 1. From 3 to 4, we add 1. From 4 to 5, we add 1. And for each term in the sequence, as we go from one term to the next, we add 1. This indicates that it's a linear function, specifically with a slope of 1. On the other hand, for the second sequence, to go from 2 to 4, we're adding 2. To go from 4 to 8, we're adding 4. From 8 to 16, we're adding 8. And we can see right away that this is not a constant thing that we're adding to get from one term to the next. So this is definitely not linear. On the other hand, what we are doing, as you can see, to go from 2 to 4, we're multiplying by 2. From 4 to 8, we're multiplying by 2. And indeed, for every term in this sequence, we're multiplying by 2. This means that we're dealing with an exponential function with we could say that b equals 2, since we're doubling each time. What about this one? We'll notice we're subtracting 2, and then we get into fractions, so this definitely isn't going to be linear. But we could see to get from -3 to -1, we multiply by 1/3. From -1 to -1/3, we multiply by 1/3. And for every term in this sequence, we multiply by 1/3. So this is exponential. And the b in our exponential function will not be 2, but will rather be 1/3. In this last one, we could try and multiply to go from -10 to -4, but then multiplying again would give us a positive number. There's no way that's right. It looks like we're just adding 6, adding 6. For every term, we're adding 6. And so that means this is a linear function with a slope m of 6. In class, we are going to practice identifying linear versus exponential functions. We're going to explore what the graphs of exponential functions look like, and we'll start to explore scenarios that actually require exponential functions to be modeled. See you there.